Hello friends, welcome to Vivid Chemi YouTube channel. This is Vidyashri. In this video, I'll be discussing the important points that you need to remember from the chapter Magnetic Effect of Electric Current of 10th Standard. Scientist Hans Ørsted for the first time observed that whenever current flows in a conductor, magnetic effect is generated. So he observed that the compass which was placed near the current carrying conductor was showing the deflection. So by this we can tell that there is a connection between magnetism and electricity. Then you should know about magnets. So magnets are any substances that attracts iron and iron containing substances. It attracts iron or iron containing substances. Sometimes it can also attract cobalt, nickel as well as chromium. So we have three types of magnet: bar magnet, horseshoe magnet as well as disc magnet. And all the magnets are bipolar, which means they have north and south poles. Two poles are there in the magnet, north and south pole. So whenever you freely suspend the magnet, it aligns in the direction of north and south poles. So a bar magnet is in the shape of a bar. It has north and south poles. South pole is represented by S and north pole is represented by N. And you have horseshoe magnet, which is represented in the U shape. It has two poles, north and south, and even the disc magnet has both the poles. So if the front side of the disc is representing north pole, its back side will be representing the south pole. And coming to the characteristics of magnet, one thing as I told, it has two poles. Every magnet has two poles, north as well as south pole, and the like poles repel each other. It means when you bring two magnets with its north pole together or south pole together, they will repel each other. And unlike poles, means the north and south pole of two magnets will attract each other. So these are the properties of the magnets. All magnets have two poles. Like poles repel each other, unlike poles attract each other. Next important thing is to remember about the properties of magnetic field lines. So you should be knowing what is magnetic field and what is magnetic field lines. What are the properties of magnetic field lines? Magnetic field is the region around the magnet where magnetic force is experienced. And these magnetic field lines, they represent the magnetic field. So here in this diagram, you can observe the magnetic field lines of a bar magnet. Now we will see what are the properties of magnetic field lines. From this image itself, we can tell the properties of magnetic field lines. So the first property that I can tell is that magnetic field lines emerges from north pole and merge in south pole. So you can clearly see it. From the north pole, the magnetic field lines originate and they come and meet at south poles. So the magnetic field line emerges from north pole and it merges at south pole. The second property is that if you check inside the magnet, so here you can see from the south pole to the north pole, these magnetic field lines will travel. So inside the magnet, field lines travel from south pole to north pole. And also from the figure you can observe that the field lines are more concentrated at the poles. So the third property I can tell that field lines or magnetic field is stronger at the poles. And these magnetic field lines, they never intersect and also they appear in the form of closed continuous loops. So these are the properties of magnetic field lines. Next, we need to discuss about the magnetic field due to current carrying conductor. So here we will consider three cases of conductor. So first we are going to consider a straight conductor. Then we are going to consider the conductor in the form of circular loop. And the third case, we are going to consider of a solenoid. In the beginning, we'll discuss about the magnetic field due to current through a straight conductor. Then all the points how can be applied to circular loop as well as solenoid, we will discuss one after the other. Whenever current is passing through a straight conductor, the magnetic field lines will appear as concentric circles. Magnetic field looks like concentric circles. And strength of magnetic field, that depends on the strength of current. It means that as current in the circuit increases, magnetic field line will also increase. Which means more the current in the circuit, more is the magnetic field. And the direction of magnetic field, that depends on the direction of current. And as the direction of current changed, direction of magnetic field lines will also change. See here, if you see, now the direction of current is from top to bottom and magnetic field lines are in clockwise direction. See, if I reverse the direction of current, now if the current is moving from top to bottom, if this is the direction of current, then the magnetic field lines will move in anti-clockwise direction. So here the direction of magnetic field lines are given by right hand thumb rule. Now we'll see what is that right hand thumb rule. The right hand thumb rule tells that if you are holding current carrying conductor in your right hand in such a way that if the thumb is pointing the direction of the current in the conductor. So if you look into the figure, you can clearly observe you are holding your right hand in such a way that thumb is pointing the direction of current in the conductor. Then the fingers which wrap around the conductor will give us the direction of magnetic field. So clearly you can see if the current is pointing in the upward direction, how you wind your finger, okay, so that gives the direction of magnetic field. So here the current is flowing in upward direction and the direction of magnetic field lines, you can see how you are winding your fingers. So that is in the anti-clockwise direction. Now if the direction of current is reversed, the direction of magnetic field lines or magnetic field will also change. So if the current is flowing in the downward direction, then magnetic field lines will move in clockwise direction. You can clearly see it in the picture here. So if the current is in the upward direction, magnetic field lines will move in anti-clockwise direction, and if the current is in the downward direction, magnetic field lines will move in clockwise direction. So this we can tell it from right hand thumb rule, and this is what is right hand thumb rule. So whenever you hold a current carrying conductor in your right hand in such a way that your thumb is pointing in the direction of current, then the fingers which wrap around the conductor will give the direction of field. So this is very, very important, and this is how you can identify the direction of magnetic field in case of current carrying conductor. One more point that you have to note here is that as the distance of object increases from the conductor, the effect of magnetic field which is acting on the object will decrease. So this in other words can be told as more the distance of the object, lesser is the effect of magnetic field. So these are all the important points that you should note with respect to the magnetic field due to current through a straight conductor. Now these concepts is very important. The same thing is used in case of circular loop as well as solenoid. I'll stop this video here. Remaining concepts will be discussed in my next video. Thank you for watching. Like and share the video if the contents provided are useful to you. Subscribe to my channel for more updates.